Welcome everyone to the Science of Testing. Appreciate you taking the time out of your morning to learn about the connections between research science and software testing. We're going to learn about some of the practices that we can engage in software testing that are taken from research science to help make it more robust. First, a little information about myself. My name is Thomas Haver. I work as an automation architect. Before I was in IT, for more than a decade, I was a research scientist, so I'm talking to you from actual practical experience. I worked on molecular fluorescence spectroscopy and microscopy, hence the fun background you have here. I also worked as a baker, so I started doing it at the end of my career in science and through my beginning of career in IT up until I got married. Still my favorite job, working as an overnight baker, because you immediately get to see the result of your labor, delicious bread and pastries. I'm also an avid board gamer. I own around 2,500 games and travel around the world to play board games at conventions. So it takes up an entire room of my house, much to the chagrin of my family. And I'm also an evangelist for Ruby Cucumber. So I care greatly about test automation and task automation. And I love using sort of this tool set as a way to collaborate with others. So let's talk about what we're going to go through today as part of our agenda. So we're going to first try to establish a shared understanding between those links of testing and science. I'm going to give you a little bit more background about my journey from a context perspective to see the parallels between science and software testing. And then we're going to explore the areas that we may or may not be familiar with in the area of science, the scientific method, which most of us learned a form of in school, although it wasn't actually the scientific method, as we'll learn, and other activities that you can engage in to add rigor into your software testing practices to make it more reliable, trustworthy, and ultimately, we can say, credible to the rest of our stakeholders. And that involves activities such as peer review, applying deduction and induction to our testing, using practices that are present in the industry like session-based test management for exploratory testing, as well as hypothesis-driven development. So before we really truly dive into this, as I mentioned, I have audience interaction. So the first question I have for those of you in the chat is, consider how testing is viewed in the workplace. So can you describe for me in, say, tweet length, so a sentence or two, how testing is viewed in your workplace? Thank you much, Dustin. I think we've perhaps met before. I mean, I've definitely recognized the last name as being one of the coolest names in tech. Yeah, at this point, I would say I have a little bit of conference fatigue. I'm on like 85 or 86, so sometimes I forget names, but you'll never forget the name Dustin Doom. So I leave this optional, sort of as part of the ground rules for folks participating. You can elect not to and just sort of be passive watchers. But if you want to, it's much appreciated. I can, of course, provide some additional context. So Jessica's testing is novel and very important, sadly, through trial and error because they didn't use it before. What else, if anyone else wants to participate, consider how testing is viewed in your workplace. I can tell you at my current place of employment that it's more of considered an afterthought. And in fact, yesterday evening I had a meeting discussing whether we should even have people in the quote unquote QA or QE roles versus just having developers take on those duties entirely. I know a number of companies have gone down that path. Anyone else care to share? We're all friends here. Unfortunately, though, it is being recorded, so it's possible for your comments to be reviewed at a later date. Dustin says it's an afterthought here. We tried to do TDD, but it ends up being domain driven and then tested afterwards. And also for context for everyone, I will just be repeating what people write in the chat just because it may not be as visible from this recording. Wayne says it's time consuming, expensive. UAT pulls resources of non-tech to make them learn technical terms. Yeah, I would say that the comments we have from Jessica, Dustin, Wayne, and myself are fairly typical, that sort of the testing phase, whether it's like a pure phase talking about UAT or functional testing, is considered mostly an afterthought. The baking in quality into our activities, us writing unit tests, going through process changes in terms of work intake for the teams, writing integration, having security scans, even like running other code analysis tools. Not necessarily the upfront versus we have to push through these features super fast. Okay, it's a similar question though. I'm going to ask you about your own view. Consider the difference in how people view science and scientists compared to testing and testers. Again, I can provide my sort of initial viewpoint going from science to software testing is whenever I've had to go through and do, say, a job interview, and they look at my resume and they see the science background, it's typically taken as a big bonus by others, like, oh, you must be smart. Put this in quotations, just because of this background in science, even though I may not have any experience with any of the actual technology for the position. You come in with that sort of superiority, quote unquote, because you had a background in science, that you must be a very technical person. I'm not sure about your own positions, just this is your own viewpoint. Whether, you don't have to have spent time in science or have been a scientist to have a viewpoint on how you think like scientists are viewed versus software testers. We think about how we see it in media. Scientists in like disaster movies are always like the geeky guy or girl who tells you exactly what's going to happen, but no one listens to them. And there's always some other dude saying, it's like, put it in English. So Jessica's testing is valuable because it helps make software hardware usage more useful and error-free for the end users. Anyone else want to share their views on scientists or science? As a scientist, you start with that credibility. Testers, on the other hand, feels like a guarded door to functionality. I would agree as well. So the key term that Dustin was getting at that I mentioned is that credibility. Like scientists have that sort of instant credibility. What they say may not make any sense. Their opinions also may not make any sense, but they have that credibility baked in because we think of science as being this sort of like ivory tower. And I caution you against that. Whenever you hear the news talk about, hey, a recent study showed blah, 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 keep in mind, whenever the news talks about a topic that you are well informed about and you say, well, they got that wrong, they do the same thing with regarding science. And there's a whole bunch of people who have different views and have differing results. Otherwise, we would do things exactly the same and we'd all get the same results. So we have that baked-in credibility. So I'm going to talk a little bit about my own journey from research science to software testing. So as mentioned, I was in research science for about 10 years. I was at 3 different research institutions, collected a number of degrees, and a massive amount of student loan debt. Eventually, I made my way into IT by the virtue of a number of friends of mine that they were all in IT. They thought that I would make a very good transition because I did have that analytical mind. I did have programming experience from the way in which I had to actually analyze my research data. And they figured that it would be a pretty good transition because when you're working, say, in the programming field, you deal with a lot of abstracts. And you do the same if you're working. In my case, I was in physics and then in biophysics as a field. You work well in that analytical domain. When I made my way eventually into IT, I worked at multiple different positions. So I was a Java programmer. I also worked as a requirements analyst, and I also worked as a tester. In fact, I did all 3 roles on one of my early teams. But I most identified with software testing. And that is because that there are a lot of parallels between research science and software testing in terms of the observations that you make, the hypotheses you generate, which can be equivalent to, all right, you're going to make experiments from that as a scientist, or you're going to write tests as a tester. It involves a lot of informing your opinion based upon observation and experimentation and relaying that information to others. And so I'm most identified with software testing, and that's sort of where I've pursued my career in, whether that be in quote unquote the manual space for testing or in test automation. So we're trying to establish a baseline of like, all right, we talked about testing, like what is testing? So here's a collection of definitions from some of our industry experts on what is testing. James Bach said questioning a product in order to evaluate it. Ken Kaner, who's actually a professor of testing down in Florida, says empirical technical investigation of the product done on behalf of stakeholders intended to reveal quality related information of the kind that they seek. This is definitely an academic's answer. But there's a key point in here, empirical evidence, revealing information, not simply doing a does this pass or fail, but providing context. My preferred answer for this, my personal preferred answer, is from Elizabeth Hendrickson. She is the author of Exploratory Testing. She says, designing an experiment to gather empirical evidence to answer a question about a risk. This is the same answer that you would also give if you were working in science on a given project or initiative, that you're designing those experiments to refute your hypothesis. You use empirical evidence to do so, and you answer the question as in, do you refute the hypothesis or does it actually end up supporting? In this case, the context she's saying is a risk, because that's what we work in the realm of testing is what is the risk? Because we can never be completely sure that the software that we're working on is completely defect free. We can tell you areas where there are no defects, but we cannot tell you that it's defect free. And hence, every bit of software testing is about understanding risk. So we ask another question of the audience. So some of you may be hiring managers. Like I was a manager, had most 25 people on my team. And so you try to look for people who will be good sort of team players or fit the role from a technical standpoint. So what attributes do teams or managers look for in a good tester? If you were to interview someone or hire someone, what would you expect? Again, switching back, what attributes do teams or managers look for in a good tester? I would also say this is where when we're doing this face to face, it's much easier for people to just like hold up their hand and say, hey, I'm a hiring manager. This is what I want. So Dustin says a lateral thinker, someone who looks at a problem from several different directions. Exactly. Like we could find anyone pretty much off the street and have them go through a procedure and say, test that this works, go through a happy path. That's fine. And that's a form that we do where we bring in customers to learn about their experience and take surveys. But it's not sort of like truly testing the bounds of something that we're working on. Jessica has being a person who is thorough and pays attention to detail and willing to provide feedback if they feel something isn't user friendly. That's also a great answer, Jessica. Anyone else care to provide feedback before I switch on to the next? I will jump over. So the attributes that we look for in a good tester are similar to some of the answers you brought in there. Someone who's analytical, inquisitive, so they're curious about the system, not just what's written down. We want someone who's passionate, reflective, and also, I think important for any role, is being a good communicator, especially if you're working on a team. If we were to ask that question again, but ask it about a scientist, we actually come up with the exact same answer. The same skills that we expect in a good software tester are the same skills that we would expect of a scientist They're analytical, they're technical, they're inquisitive, passionate about their work, reflective on the work that has been done, and good communicators. It's a complete overlap of skill set. It's just a matter of what their focus is, whether it's knowledge for the sake of knowledge, that's science, or exploiting it for some technology purpose, like that is us working in the software field for development. So William McConus said that close inspection will reveal that scientists approach and solve problems with imagination, creativity, prior knowledge, and perseverance. Do testers do the same? Absolutely. I would say especially the good ones, that they use that imagination and creativity to explore the system so they can provide information that they've observed about those risks to their stakeholders, to their team members. So we learned in school about the scientific method. Most of us had, biology, chemistry classes going up through grade school. And what do we end up doing? Well, we ended up writing in a lab book or maybe a worksheet, a procedure that we followed with some expected result in mind. But this actually isn't the scientific method. The way that we have learned it and the way that we continue to teach it in school is actually completely wrong. So again, we state the purpose of science is the pursuit of knowledge for knowledge's sake. From the scientific method perspective, it is not a set of procedures. The scientific method is more about guidelines that you follow, because otherwise you would have multiple labs across the world working on the same problem that use, in fact, the same exact procedures, because there's only one scientific method to follow for it, and they would always get the same results. But we see that's not often the case. So it's more about the set of guidelines that we follow. And this is where we have a connection again with testing, that there can be a very procedural driven science that or testing that is based upon, all right, we want to follow a happy path for how the user is interacting with the system. But we find out, especially through incidents, defects, service desk calls, that the users don't actually always do what we expect them to do, nor does the software react always in the expected way. That can change based upon the environment we're working in, the data we have access to, the platform that we're working on. All of these things are changes to the system that can result in changes to the software that we're working on. So we talk a little bit more deeply about the scientific method of, all right, we want to better understand and apply this to testing. In general, you're trying to collect some empirical evidence. Typically, it's done via observation. We do the same thing in testing. We observe the application under test. We want to propose a hypothesis and make predictions about it. So a key component of a hypothesis is that it can be falsifiable, as in you can disprove that hypothesis. You can never actually prove a hypothesis to be true in all cases because it's impossible to test all combinations. Does this sound very similar to applications that we work on? We can never disprove ultimately. We can never show that an application is completely defect free, but we can at least disprove that, hey, this feature is free of a defect. This area works as intended. And ultimately what we do is when we build up that bank of tests or experiments, we help corroborate the hypothesis or refute the hypothesis. And what do we do? From the process of learning about each one of those experiments or tests, we can then update our hypothesis. So this is a process that's very similar to what we should apply as testers. We learn the product and observe the behaviors. We identify the risks and predict where failures can occur. That's where we create our test coverage. And we execute the test to confirm the failures. In this case, the principles that you would follow for the scientific method are very similar to those that you would follow for testing. Let's use an example here. Again, this is another chance for audience interaction. So here's an example of a mobile app. In this case, I use the mobile app for the Toronto Maple Leafs. They advertise when you're trying to download this from the Apple Store or Google Play Store that you follow the game live, you can preview upcoming games, you can get recaps from past games, you can receive score alerts, and you can interact with other fans. So with these being sort of the proposed features and your knowledge of mobile applications, what would be some areas that you would test? So we have a question here. So we have just asking, how would you define technical as an attribute of a tester? So Jessica, I'd say technical can be in multiple different areas. So one of those can be domain knowledge, as in they understand the business logic that we're implementing. Technical could also be they understand the tools and technology. So someone who can say write Python, Ruby, C#, Java, understands the tooling that we use like OpenShift, Azure, AWS, understands Flutter for mobile apps. Like those are some examples. So one can be the domain, the other can be on the tooling or technology side, and that's how you make someone as technical. For instance, there are a lot of business analysts I know that I would describe as very technical, but have not written a line of code in their life. That is because they understand how the underlying source systems work for the application. So that's the context when I say technical. So if we were to zip back for this of application to testers, those who can follow the game live, preview upcoming games, get recaps, receive score alerts, and interact with fans. If we're going to apply those principles of the scientific method, which we're now saying it's going to be software testing, what would be some areas we would explore as testers? Realize this can be a difficult request given what I just provided to you, thinking about in different ways of how would you observe that system, and what would be some areas that you could end up discovering, as in they could be falsifiable. I will provide an example to get us started here. So we can say follow the game live. How could we actually write a test that would refute this? Well, one of those is removing any sort of network connectivity. Like we want to explore the failure point to confirm it can fail, because a test that can never fail or we can never determine that it fails is actually a bad test. It's a false pass is just as bad as a false failure. So if we're going to follow the game live, then I would write a test case that would remove all network connectivity and see what's being reported on that app. Is it showing that the network connectivity is removed, or am I still going to get the indication that it's live without any sort of updates to it? What about the rest of you in our chat? Anything else that you can think of ways in which you can quote unquote refute the hypothesis, as in prove that these functional areas are going to fail? Again, it's okay if people do not want to participate. We're all adults here. Even better than the in-person talk, we can jump on our phones as needed and no one will know. So Jessica, give it to someone who's never used the app before. Well, I would say that's a different form than what's intended by this activity, Jessica. What I'm looking for is in mirroring what we have found about the scientific method is we need to have a way to corroborate the hypothesis or refute the hypothesis, as in we need to have a way to falsify our claims here. So we have these functional areas, and I provided one. We advertise we can follow the game live, and to falsify this, to prove that it cannot work, is for us to remove the network connectivity of this phone and observe the results. Will it still portray the game as being live, even though we can't actually check on the game status? That is a way for us to refute this feature. So what are some other ways in which we can do it? Remove the past game access to past games and look for errors. That's exactly one of the examples I was looking for, Dustin. Thomas says, have app open with connections while watching a game on television. That is another one of, all right, if is it actually updating live on the app to match what you're seeing live in person? So these are all excellent examples. So the lesson learned from this activity is in our testing, it's not just simply about finding that happy path. We need to prove that our features will fail and see how the system behaves when it fails. So this is an important sort of part of science as well as software testing. The idea of falsifiable claims. The principle of falsifiability comes from Karl Popper in the 50s. So science aims for falsifiable claims and not claims that cannot be verified. Is that you need to have empirical evidence to prove something works as well as prove the conditions in which it does not work. So we can never be truly sure that our software is defect free, but we can provide evidence on the risk associated with releasing. Edgar Dijkstra wrote, testing can show the presence of errors, but not their absence. And this is sort of one of the areas in which QA gets hurt from a credibility standpoint. We ask the question, did we test this before it released? Yes, we did. Well, then why were there defects in there? Well, that is because we can show the errors that we found, but we can never show hey, that it's completely absent of any defects whatsoever, because it is impossible for us to test sort of all combinations of a system. So if we dive back into this of our falsifiable claims that we look for, and we want to explore other areas of this application, say preview the upcoming games. Well, what's another good example of preview of upcoming games is what happened with, say, COVID. Of, hey, what happens if the games are actually canceled? All right, if the games are canceled, are we still going to show the preview of those games present or not? So just as I'm giving it to someone who hasn't used it, it will show us what we think is the best way to approach something versus what the average user would think. I would say again, that's a good approach, and it will be in later portions of this presentation, Jessica. However, that is not about the falsifiability strictly in terms of the application functionality. It can be about the user experience, though. And I think that's probably what you're thinking of. So there's sort of two different components of this, from an empirical evidence state. One is an objective and the other is the subjective component of it. So subjective falls more in lines with what you're saying. Also user surveys of how much did you enjoy this? What's the net promoter score? Those are good examples. And I'd say the subjective observations are as important as the objective. Right now, I'm talking about the sort of the empirical evidence that would come from those objective observations. All right, so let's talk about adding in some structure to our testing approach. We want to try to add credibility to software testing that we already have present in research science. So one of those ways is peer review. So in science peer review, it's a way for us to check the work performed by one's equals, known as peers. Peer review often occurs when you're trying to publish research papers, and it can all be a multi-year process from the point at which you are done with your research to when it's actually published. We obviously can't have that degree of downtime between when we're working on a feature for software and when we actually want to push it to the users. The shortest amount of time we're looking for is trying to push those changes on the same day if we can. So then how do we adopt peer review then? Well, peer review can take multiple forms. So one of those forms that we would adopt is simply the approach, the strategy and planning that we have in place, this sort of guardrails that we put around our testing activities. So we want to have someone as a peer outside of that team reviewing what our strategies are for testing, what are the approaches that we're going to be taking and actually testing the software. The other is as a part of that post-mortem, post-release, we finished our testing process. Well, we want to see what were the test cases you generated? What were the tools that you used? What were the data that you used, environments that you used? We want to go through a peer review of our approach. So that way we can refine our approach for future releases and make updates. It's also part of that learning process of people who may be, quote unquote, more junior or less experienced will learn from having that outside eye. We compare this to, say, software development as well. We don't call it peer review, we call them code reviews from a development standpoint, and we have at least one other person. And we also now have opportunities via the tooling we use for our build deployment pipelines to do required peer reviews before those changes are merged. So that means we can require 2, 3, or 4 people in different roles to review our code. So we should take that same approach with testing. We should try to mirror the best practices, or quote unquote good practices, in development to also what we apply for testing, which is also, as we see, in science. So just checking back to see through them. Another form of an approach that we can take is in the actual testing activities. So I provided one example, which was falsifiable claims. Another is deduction. So deduction is making a specific conclusion from general knowledge. So this is an approach that we would take to testing our application. Let's give an example. Right? We have all likely heard about the Galaxy Note 7s and the problems with the batteries. So from a deduction standpoint, we know that there is a factory defect that applied to all Galaxy Note 7s. So if someone were to provide me with a shiny new Galaxy Note 7, then I could reasonably conclude that this would also turn into a flaming brick. You apply the same approach to testing software. If you see a common problem, say against all mobile applications or against a common browser, then you can reasonably presume that you are also going to see that same issue. So you should apply test cases to that. From an deduction standpoint, this is where you make general conclusions from specific knowledge. So this is us extending that knowledge. Let's just say that we know that geolocation doesn't work on the Edge browser. So, all right, what would we want to explore from this perspective? Well, we'd want to test it on the other browsers as well, because even though this is something specific for Edge, we could create a hypothesis that this geolocation issue applies to other browsers as well. So this is how we come up with what we consider to be adequate test coverage that is of a reasonable format, that, all right, applying deduction and induction to find those problem areas, whether it's general to specific or specific to general. Another area that we can add rigor for science is exploratory testing with session-based test management. Now, like, my primary role is working in the test automation space, but exploratory testing is probably the most valuable activity you can engage in from a quality standpoint. So James Bach, one of the co-creators of exploratory testing, said it's simultaneous learning, test design, and test execution. Think of it almost as a game of 20 questions, where each answer you get from a question informs the direction which you're going to go in the future. It follows the same sort of guidelines that you would expect now from the scientific method, where you're learning, designing new tests, executing them. From the feedback, it informs you in the direction you're going to go in the next space. It's a way for us to interact with that system, designing and executing tests in succession. And those results inform our next step. In this way, it's very adaptive, similar to how the scientific method is adaptive, that the results from our experiment inform us, will lead to us updating our hypothesis and doing additional experiments, or tests in this case. So this is going to find out a lot of the capability and limitations of the software beyond the simple like happy path or sad path that we could create. That's sort of the bare minimum from a testing standpoint. So how do we actually make this something that is like part of our process? One is showing that value proposition from the exploratory to the scripted side. Most of our testing activities are purely in the scripted side. That's based upon requirements. We've defined them in advance. It's very confirmatory, like, hey, we're going to verify that this happens. And we should predict, like, this is what the end result is going to be, either a happy path or sad path. So we've already decided up front what it's going to be. That is just one end of the spectrum, though. The other end is exploratory. So when we're committing to only scripted testing, we are committing to reduced QA activities. We are limiting ourselves in terms of the information that can be gleaned about the system, so we can provide that feedback on risk. So When we're saying scripting, we are really cutting out of one side of the spectrum from the testing standpoint. But we want to make sure that the value proposition from conducting exploratory testing is as realized as the scripted portion, because it's very easy for us to generate, say, metrics around, hey, you've tested this many features, you have this many test cases, this is your defect escape rate. There's all sorts of metrics in that space around scripted testing. Not as many in the exploratory side, which is why you don't see as widespread adoption, because you need to see, like, hey, what are you gaining from this? And this is where session-based test management has value, is it allows you to add that accountability from an empirical side, that you generate status reports that reflect on what you did, provide detailed maps of how you traveled through the application, and can be used to generate metrics. I'm going to touch base real quick, see if anyone has any comments. Nope, and I'll go right back in. So what are we going to have in a session-based test management? You're going to have a charter. This is where you're going to begin your journey. A time box. How much time are we spending on this? Reviewable result. Debriefing. And our charter is going to have a clear mission for that session. What are we going to start with? It's not going to necessarily be the endpoint, but what we're starting with. The charter takes the form very similar to a user story of, I'm going to explore a target with these resources to discover this information. The target is what you're exploring. The resources are what supplies you're bringing. And the information is what are you hoping to find. The time box is that focused test effort of fixed duration. This makes it easier to build it into your planning of, hey, we're saying that we're going to devote X amount of time for our testing activities. Let's take a portion of that and make that exploratory. The time box, though, should be brief enough for you to at least accurately report what was done. Flexible in your scheduling, as in we're going to conduct this for 30 minutes or for 1 hour on this given user story. That will allow for you to correct courses if you find interesting information, but long enough so you can actually get solid testing done, and for you to have debriefing with that peer or that manager. One of the end results, the deliverables from this session, is a scannable session sheet. That scannable session sheet will contain your charter, your start and end time, who was involved in testing, the breakdown of your activities, any data files that you used, any additional notes you had about things that were found, especially the bugs that you found and recorded, and any other issues you had in getting set up. Most of the time that people spend in actual testing activities are around setup and teardown, like actually getting access to the system under the circumstances that would perhaps mirror what users are going to see in production. So here's an example of one of those reviewable results where you break down your activities, you record what you've ended up finding and those test notes and bugs, and then you can actually combine this. Cool thing about many of project tracking tools out there, like TFS, now it's ADO and Jira, is you have plugins for exploratory testing that will actually record your session live, that will allow you to input information, so that way you can turn them into metrics that can be viewed, metrics that can give you information about what's the state of the system. One is we want to make sure the person testing it understands the system. So that's why we want to have a debrief. We want to make sure to answer any questions that could be outstanding. It could be due to data or environment or just their understanding of the features. We want to generate those session metrics, and we can adjust the charter for future sessions. So collecting this information and aggregating it will help us identify where we have gaps in our application. That session itself may be extended in the future if you found some interesting information and need to dive deeper. Again, you're adhering to your time box. So that's why you can generate new sessions, but you're having it at this checkpoint. This is also an opportunity for coaching. So in a debrief session, it could be, say, a QA manager working with one of their directs, or it could be a lead or senior person working with a junior person. And it's an opportunity to uplift those people, whether it's the domain knowledge or the testing approach. In the example I provided previously, it was actually 3 people conducting that session, where one of them was a business analyst learning about the system, and the 2 others were senior people in the QA space. When you conduct a debrief, we also have, as provided by James Bach, some example questions that you would ask during this session. So this provides, again, that structure, that rigor that we want to generate in software testing to help match research science. So even when we're talking about this exploratory side of testing, we can still be as rigorous as we would expect of scientists. The metrics that we would garner from this are things like the sessions completed, the number of problems that you found, the function areas covered, and the percent of time that was spent on setting up and testing and investigating problems. These are good metrics to provide because they can reveal information not just about the application, but about the organization. How much of our time is spent setting up or investigating problems rather than just testing? This is a good indication if we have more organizational issues than we do application issues. I'm going to jump back real quick to see if anyone has any questions before I move into the last section here. All right. The last section here is on hypothesis-driven development. This is, again, one of those activities that will help make software testing more rigorous and credible as science. So Barry O'Reilly is one of the sort of progenitors of hypothesis-driven development, or HDD. Most of the time that I've worked in software, we've worked under triple D, as in deadline-driven development. So hypothesis-driven development is thinking about the development of new ideas, products and services, even organizational change, as a series of experiments to determine whether an expected outcome will be achieved. So in hypothesis-driven development, the outcome of the experimental approach is measurable evidence in learning. So learning about the state of the system or the state of the marketplace and having some empirical measure to help drive our decisions rather than sort of thoughts and feelings from the creators or producers. So in HDD, you're going to make observations. This can be about the marketplace or your specific application. You're going to formulate a hypothesis and design an experiment to actually test that hypothesis. Remember, a hypothesis needs to be able to be refutable for it to be a valid hypothesis. You're going to state the indicators to evaluate if the experiment has succeeded or not. So this is your acceptance or rejection criteria. So you will end up, once you've created your experiment, you're going to conduct it. You're going to evaluate the results after some period of time and accept or reject that hypothesis. Regardless of whether you accept or reject it, you do have that ability to modify it and test a brand new hypothesis. So everything that we're doing is a learning process. The template follows same style as a user story template, same style as a session-based test management session for exploratory testing, where you're saying, we believe this capability will result in this outcome, and we will have confidence to proceed when we see some measurable signal. When we say we believe this capability, what we mean is a test capability of the product. It's functionality, perhaps, and it's something that we're going to have a hypothesis determine whether it's true or not. The outcome is the expected outcome of the experiment, what we expect to see. And lastly, the confidence measure is the criteria to reject the hypothesis. It has to reach a certain threshold, otherwise we will reject it. Thus far, I've been talking in the abstract. And I've been talking about the way in which we test. This changes sort of the mindset for our approach for testing. We're not simply testing features, whether they verify the functionality was built, the so-called producer viewpoint of meeting requirements and building the right thing and on budget. We are trying to take the customer viewpoint, where we're looking at, is it the right product for them? Does it meet their needs? Are they treated well? We're trying to close that gap between the producer and the customer viewpoint. This is known as the two quality gaps in the industry. We want to bring those as close together as to what the actual product we produce, because what we set out to do and what we actually deliver, there's some differences, also known as a gap. What the customers expect and what we actually deliver, there's also a gap. So by us trying to bring together the customer viewpoint, as Jessica actually put in the chat, is a positive thing. It changes the way in which we think about testing. I'll give an example. I mentioned at the very beginning of my talk that I worked as a baker. I worked as a baker for Panera. So if we're going to create an HDD for Panera, we'll say, we believe that increasing the size of niche images on the My Panera registration page will result in improved customer conversion. We will have confidence to proceed when we see a 10% increase in the customers completing My Panera registration over the registration page with the original niche images. You may note the strong similarities from HTD to now what we in the industry call A/B testing. And that is because they're actually one and the same, but just framed differently. So A/B testing is about sending a certain portion of your customers to one experience, a certain portion to the other. And then you are going to check that measurable result. In this case, we have a regular looking niche and we have a gigantic niche on the My Panera page. And we're looking to see how many people actually sign up and register for My Panera. We found that those who went to the large niche image registered at a greater rate than the small. So what was our criteria? It was that 10% difference that we had. In this case, we're at 15. So yay, what we would do is we are going to accept this change and we're going to use the large niche image going forward. And we would set up other A/B tests. I would say A/B tests are very popular for Amazon, Google. They conduct, say, thousands per day. Also very common in any sort of like e-commerce system of you're looking at customer behavior by setting up these small experiments for them. And then the results of that experiment will lead to you adopting that change or rejecting it. And this can be somewhat of a culture shift within an organization because they're pot committed whenever they develop a feature. No one likes to sort of roll back a feature once it's in production because they put all that time in. It costs money, it's going to affect our project budget. But ultimately, if it's about the customer's needs and driving those positive results, we need to be ready to reject any work that we've done. And of course, like, who wouldn't want to sign up for My Panera when they see this delicious miche? By the way, this is a sesame miche. They always get 5 cuts like this. Depending upon the miche, you're going to get different cuts on your bread. So in conclusion, science and software testing share parallels in both observation and experimentation. The rigors of science should be used to help understand and inform software testing, both for those testers and outsiders. The skill set that we expect from scientists is the same skill set we actually expect from testers. They just have that credibility gap because it's a different role. But by adding in those rigorous activities into software testing, we can build up that credibility. We can make our testing activities better, as well as the perception of those testers by those outside. So thank you very much for your time. I'm open for some additional questions, and then we will wrap up. If there are no other questions, if you want to get in contact with me, this is my email. I'm also on Twitter, and you can find me on LinkedIn. If you're interested in a copy of this presentation, let me know. I can send it to you. Thank you very much for your time. I appreciate it. The rest of you have a good day.